How's it going, guys? Welcome back. This is Module 4 as well, still, the Brew House. We are now on Kettle editions. I'm Chris Johnson from Green Bench Brewing Company, and here we go. Let's see. All right, so talk about our Kettle editions, the different things that we add during the boil. We'll talk about hops, finings, acids, fermentables, spices, and our required reading for this module, for this specific slide. Chapter 11 of the Brewer's Handbook. Kettle additives. So again, part of the required reading. Take a look at it, listen to the slide, get ready for the quiz. There'll be some stuff in there about that one. All right, so hops. We'll talk about that first. There's a lot on this page, and I do realize now that my head is in the way. So I'm going to read through them, and you guys can pull these up. Obviously, we'll provide these. All right, so hops. The timing at which you add hops is very important, as the first line says. I know you guys spoke or learned a lot more about hops in a previous module. We won't necessarily go into the science of the hops because of that, but we'll talk about what the hops contribute to the boil, which is where we're going to add the hops first ever, usually to brew. So, longer boil times result in less flavor and aroma and more bitterness. So if you boil it for longer, you're going to get more bitterness out of it, less aroma and flavor. The longer you boil it, the more aroma and flavor you actually evaporate off. So you're going to lose aroma and flavor if you boil it for long. However, shorter boil times will result in more flavor and aroma and less bitterness. If you don't boil it for very long, you won't boil off the aroma and the flavor. You also won't get a whole lot of bitterness. So, early additions, bitterness. Later additions, aroma, flavor. Traditionally, early hop additions are bittering hop, and late hop additions are flavor and aroma hop additions. So if you add early, you're going to get bitterness. If you add late, you're going to get flavor and aroma. Every hop, however, has a completely different flavor, aroma, and bittering capability, even crop to crop. So sometimes it's the exact same hop, depending on the crop year and the crop time. We'll have a different flavor and aroma. We'll have different flavor contributions as far as bitterness goes and what they can give you. For example, if Cascade in crop 2012's alpha acid was 6.1% alpha, and Cascade crops 2014's alpha acid is 7.4%. And both hops were added to the exact same beer at the exact same time. So imagine I have a boil here, I got a boil here. I have hops, Cascade 2012, 6.4%, or 6.1% alpha. Hops here from 2014, 7.4% alpha acid. At the exact same time in the boil, I added both those hops, the exact amount of boil, the same beer. The 2014 crop would lend more bitterness because the alpha acid is higher than the 2012's crop. So, same hop, same amount, same boil, same time, everything. Higher the alpha acid, the higher the bittering capabilities that you're going to get from that hop. So it's very important to sort of know as you move forward. Flavor and aroma works the exact same way. If I pour in a 2014 hop and a 2012 hop, same exact hop, different crop year, you're going to get different characteristics in both your flavor, your aroma, and definitely your bitterness. So here are some of the hop additions that are common. So there's this first word hopping. First word hopping. First word hopping is when you add hops pre-boil while you're lautering. So adding hops to the kettle during lauter prior to the boil. You're going to get flavor, you're going to get medium bitterness, and you're going to get little to no aroma. Bittering addition. This is adding the hops at the beginning of the boil for bulk bittering contribution. So this is where you're basically just going to get bitterness of this. You get little to no flavor, maximum bitterness, and you don't get any aroma from these hops at all. Then you have your flavoring addition. This is going to be a little bit further into the boil, closer to the end. Adding hops near the end of the boil, high flavor, low bitterness, medium high aroma. So you know, decent aroma, a lot of flavor, low bitterness. Then there's an aroma addition. Aroma additions are adding hops at the end of the boil, near the end of the boil or at the end. So adding hops at the end of the boil, medium high flavor, very low bitterness, very high aroma. So that's what you're going to get out of those sort of different hop additions, just as a rule of thumb. Lastly, about the hops. Hop usage amounts completely vary depending on the hop statistics. So for example, the alpha acid, that kind of thing, will completely change how much you're going to add. What also changes that is brewhouse configuration, brewhouse efficiency, hop utilization efficiency, and wort makeup. So depending on what your wort makeup is, depending on how much dark grain versus light grain you have, depending on the pH that you're starting with, depending on the gravity, depending on how your brew house is built, depending on if you're transferring any of this wort, depending on how long your whirlpool is, your process is, depending on how high your efficiency is in your kettle. Some kettles are far more efficient at isomerizing hops than others. All those are going to change the makeup on exactly how much hops you need per addition, depending on what bitter flavor and aroma you desire. This takes time to sort of figure out when you start with a new tank, or new brew house rather. So, International Bittering Unit, IBUs. IBU is a theoretical scale used by brewers to determine how bitter a beer is. You'll hear IBUs all the time. Every beer is going to have one. They are important to know. What's more important to know about IBUs, in my opinion, is that they are theoretical. So as I mentioned here, theoretical does not always equal true bitterness units. That can only be qualified in a lab with a UV spec. So by using UV spec in a lab, it'll punch out, it'll just yell out to you exactly what the IBUs are in this beer based on the isomerization that you had and sort of what is sort of fallen out of suspension via fermentation, packaging, aging, clarification, any of that. So you don't actually know what the true IBUs are until you test that. What's the most important thing about IBUs, though, well, you can qualify both theoretical and true, is the perceived bitterness, which cannot be qualified. However, it is the most important of all three, because what is perceived is what you taste. And if it's too bitter, yet it's coming out 20 IBUs, the actual number doesn't matter as much as what you taste. So something can be extremely bitter but doesn't read highly bitter, or the opposite way sometimes as well. Something can read extremely low bitterness but be extremely bitter. Something can read very high bitterness but not be bitter at all. So finding that perceived bitterness is the most important factor. All right, so findings. Findings are things that are used to sort of clarify, find the beer before usually fermentation. So Irish moss, which is the most often used in the form of whirlfloc, which is basically it is Irish moss, is a kettle fining agent that assists in wort clarification. You either usually buy whirlfloc in a powder format, tablet format, or capsule. Wort contains a high volume of positively charged proteins. So Irish moss, also known as K. carrageenans, has a negative charge, and it assists in precipitating the proteins in the wort. So basically, you add a negative charge, the positive charges bind, they coagulate. So dosage amounts varies on the brewery, depending on what they want, based upon kettle design, water profile, recipe makeup, lots of things. Find what works best for you and your brewery, and I know the brewers will definitely know exactly what works best for them, but most breweries use whirlfloc to help clarify. Irish moss, it does become denatured at high temperatures. Therefore, the addition time is pretty important. It's usually added at the end of the boil or the whirlpool, not like in the heat of the boil, because if it's really, really hot in the boil, it can again become denatured. If in powder form, usually it's mixed with cold water before being added to the kettle, because the cold water will actually allow it to dissolve a little bit easier, and you can get it kind of mixed in fairly easy. You just pour the powder in, it's pretty hard to get it mixed into the kettle. Acids. All right, so some of the most common acids used, tannic acid. Tannic acid is sometimes used to reduce color, it improves clarity, and it softens the bitterness utilization that you're going to get from your hops. There's also phosphoric acid, which is often used to drop the pH of the boil and or soften the bitterness utilization. Again, higher acid levels, i.e. lower pHs, will decrease your isomerization level, so you won't get as much bitterness from your hop additions. Lactic acid is sometimes used to drop the pH of the boil, soften the bitterness utilization, or it's sometimes added for flavor if you're trying to get some acidic characteristics. And there's also calcium sulfate, which is gypsum, or calcium chloride, which the key there is the calcium amounts, which is often used to lower the pH of the boil. So a lot of times there'll be gypsum or calcium chloride additions in the mash, or the latter of the boil, in order to drop the pH of the boil. Okay, let's talk about some fermentables. So fermentables are simple sugars that are often added to the boil to increase gravity flavor or assist in drying out the final product. And what I mean by this is that obviously we have fermentables in our wort that we create through the enzymatic conversion that is the mash. However, a lot of times brewers will add fermentable sugars, and so these are the ones. These are these simple sugars that are added. And again, sometimes to increase gravity, flavor, or assist in drying out the final product. For example, corn sugar is a very common one. It increases the gravity, so it gives you extra sugar that you're not actually extracting from the grains. It's just sugar that you're adding in the boil. It doesn't lend any flavor, which is key. And it definitely helps dry a beer out. Sometimes a lot of breweries will make, for example, imperial IPAs, double IPAs, and they want them extremely dry. And they're very hard to dry out because of the high gravity, because it's very difficult to get that many fermentable sugars, and it's hard to get the yeast to ferment out that much sugar. So they'll often use corn sugar. They'll add corn sugar in the boil, which will get them the rest of the way for their gravity. That way maybe they don't have to mash in with a super high gravity beer. They can get the rest of their gravity from corn sugar. It's also an extremely simple fermentable sugar, so the yeast can kind of break it down fairly easily. There's also clear syrups. They lend soft sweetness. Amber syrups that give soft caramel. Dark syrups impart dark fruit and delicate burnt flavors. Sometimes brewers also can add fruit to the kettle for flavor, which is not often, but it does happen sometimes. For example, I guess I did make a beer once where I added Chardonnay grape must, but it wasn't actual fruit, it was the must of it. So that's as one example. Then again, there's also spices that are fruit flavors. So for example, spices, the hot temperature of a boil can act as an extractor of flavor similar to tea. So a common spice addition would include coriander and orange peel in a Belgian wit beer. So that's an example of a fruit and sort of a spice addition that is very common. This happens almost every Belgian wit beer needs some sort of coriander, orange peel, spicy characteristic, spicy spice rather, and usually a citrus peel. So, all right, that'll do it for this slide. See ya.